Hello. Welcome to my channel. In this segment, I will discuss setting up and using active and passive buzzers for Arduino boards based on AVR microcontrollers. We will get familiar with the functions and libraries suitable for working with buzzers. First, let me explain a bit about active and passive buzzers and highlight their differences. Active and passive buzzers are both used to generate sound, but they operate differently and are suitable for different applications. Here's an overview of both. Active buzzers. Definition: active buzzers have an internal oscillator, which means they can produce sound simply by being connected to a power source. They generate a fixed frequency sound when voltage is applied. Operation: they do not require an external signal or oscillation to produce sound. When voltage is applied, the internal circuitry drives the buzzer to emit sound. Control: easier to use because they only need a DC voltage to operate. Applications: commonly used in simple alert systems, alarms, timers, and indicators where a constant beep is required. Example: when connected to a 5V power supply, an active buzzer will immediately start buzzing at a specific frequency, typically around 2 to 4 kHz. Passive buzzers. Definition: passive buzzers do not have an internal oscillator and require an external signal, usually an AC signal or a square wave, to produce sound. They act more like a speaker and require an external driver circuit to generate sound. Operation: they need a varying signal to produce sound. By varying the frequency of the input signal, the sound frequency can be changed. Control: more flexible as the frequency of the sound can be controlled by the input signal. They can produce a range of sounds and tones based on the input frequency. Applications: used in applications where different tones are needed, such as in musical toys, complex alarms, or any application where variable sound output is required. Example: when connected to a microcontroller that outputs a square wave signal, a passive buzzer can be used to play melodies or generate different alert tones. Practical considerations. Power consumption: active buzzers may consume more power due to their internal circuitry. Cost: passive buzzers are generally cheaper as they lack internal circuitry. Size: both types can come in various sizes, but passive buzzers can be more compact due to the absence of internal components. In summary, choose an active buzzer for simple, straightforward sound generation with minimal control requirements, and choose a passive buzzer if you need flexibility in sound frequency and are able to provide the necessary driving signal. When working with buzzers, both active and passive, on Arduino, there are several libraries that can help you generate tones, melodies, and sound effects. For active buzzers, you can use the Arduino function digital write due to its simplicity. However, for passive buzzers, I recommend using the tone library. It's important to note that the tone library uses the microcontroller's hardware timer, which may conflict with other Arduino libraries. For example, you cannot use the servo library and the tone library simultaneously in a project because the servo library utilizes timers to generate PWM, and the tone library also uses timers to produce a PWM signal with a specific frequency and a 50% duty cycle to generate sound in the buzzer. Due to the limitations of the tone library, I prefer to use active buzzers in my projects so I can utilize all the features of the Arduino board for other tasks, such as working with servos. However, it's important to note that active buzzers cannot produce sounds at any desired frequency and are typically used solely as alarms. In projects where active buzzers are used, different alarm patterns can be created by generating various single-frequency sound patterns. This involves turning the buzzer on and off in different sequences and durations. Take a look at this example. In this example, different functions are written to generate sounds for an active buzzer. let's get more familiar with the tone library for passive buzzers. 1. Tone library. This is an Arduino library to produce square wave of the specified frequency and 50% duty cycle on any Arduino pin. A duration can optionally be specified, otherwise the wave continues until stop is called. The pin can be connected to a piezo buzzer or other speaker to play tones. Using this library will affect usage of the PWM outputs, so be aware. Methods. Begin, pin, prepares a pin for playing a tone. Is playing, returns true if tone is playing, false if not. Play, frequency, duration, play a tone. Frequency is in hertz, and the duration is in milliseconds. Duration is optional. If duration is not given, tone will play continuously until stop is called. Play is non-blocking. Once called, play will return immediately. If duration is given, the tone will play for that amount of time, and then stop automatically. Stop playing a tone. Constants. There is a list of constant values of frequencies for notes. These are included in the library. The library uses the hardware timers on the microcontroller to generate square wave tones in the audible range. You can output the tones on any pin, arbitrary. The number of tones that can be played simultaneously depends on the number of hardware timers, with CTC capability, available on the microcontroller. 8 Mega 8, timers 2 and 1. 8 Mega 168 or 328, timers 2, 1, and 0. 8 Mega 1280, timers 2, 3, 4, 5, 1, 0.